Copper has quietly run the modern world for well over 100 years. Power grids, data centers, factories, computers, almost none of it works without copper moving electricity and information from point A to point B. It became so fundamental that nobody really questioned it. But right now, something strange is happening. The material that built the digital age is starting to hit a wall.
Artificial intelligence is advancing so fast that shuffling data between thousands of chips has become almost as hard as the actual computing. Inside some of the world's biggest AI data centers, expensive processors sit idle, waiting on information instead of crunching it. Chips keep getting faster, but the wiring connecting them can't keep pace, and that gap has turned into one of the defining engineering problems of this decade. Engineers everywhere are trying to fix this, but one country keeps showing up with an unusual number of breakthroughs: China. In just the last few years, Chinese labs and companies have unveiled progress in optical networking, air-core fiber, glass-based chips, photonic processors, and record-setting data transmission. Each headline looks like its own story. Together, they point at something bigger. What if computers simply stopped needing copper at all? On its face, that's a wild idea. Copper is baked into nearly everything: power plants, phones, EVs, the cables under the ocean. Tearing it out would mean rethinking some of the most entrenched technology on the planet. But AI might be forcing that rethink, whether the industry is ready or not. Here's the core issue. AI doesn't just need raw processing power. It needs thousands of processors talking to each other instantly. Picture trying to hold a conversation with 10,000 people at once. Even if everyone thinks at lightning speed, the conversation stalls if messages can't travel fast enough between them. That's exactly the traffic jam happening inside today's AI supercomputers, where tens of thousands of chips are constantly swapping massive amounts of data every second. Engineers have squeezed copper for everything it's got: faster signaling, less interference, smarter connectors. But every fix creates a new headache. Electrical signals throw off heat. Higher speeds burn more power. Longer runs weaken the signal and need extra hardware just to keep it alive. As AI clusters scale up, all of these problems compound. That's why more engineers now think the next leap won't come from a faster chip. It'll come from changing how data actually moves. The alternative: send data as pulses of light instead of electrical current. Light travels huge distances with almost no loss, runs cooler, and can carry far more information at once. Fiber optic cables have already connected cities and continents this way for decades. Now researchers want to bring that same trick inside the computer itself, replacing copper traces between chips with optical links that move photons instead of electrons. This is one of the hottest research fields in computing right now, and it's exactly where China's recent announcements start to click into place. Chinese universities, telecom firms, and chip makers have rolled out one optical demo after another: photonic processors, glass-based chips, record-breaking fiber speeds, and networking designed specifically for AI workloads. Most recently, researchers reported pushing data through air-filled optical fiber over long distances at extreme speeds without needing traditional signal repeaters. The projects look different on the surface, but the goal is identical every time: move more data, burn less energy, cut the heat, kill the bottleneck. If these technologies keep improving, the ripple effects go way past server rooms. AI already touches healthcare, self-driving cars, robotics, research, finance, manufacturing, and national infrastructure. any gain in computing efficiency echoes through all of it. So swapping out even part of the copper backbone wouldn't just be a neat engineering trick. It would mark a genuine shift in how computers get built. To be clear, copper isn't vanishing overnight. It's cheap, tough, conductive, and backed by a century of manufacturing know-how. You can't replace millions of miles of wiring in a weekend. But history has a pattern. Old technologies stay dominant right up until a new one quietly becomes good enough to solve problems the old one never could. Steam gave way to electricity. Vacuum tubes gave way to transistors. Hard drives started sharing shelf space with flash memory. Some engineers think copper's turn may already be starting. Not because copper got worse, but because AI is demanding things copper was never built to handle. To see why, look at how data center demands have shifted. A few years ago, giant data centers mainly handled cloud storage, video streaming, and web apps. Heavy, but predictable workloads. AI flipped that script. Training a modern model means thousands of processors constantly trading enormous volumes of data with each other, nonstop, not in occasional bursts. The bottleneck isn't the math anymore. It's getting the data there fast enough. It's like building the world's fastest sports car and then making it fight through rush hour traffic every day. The engine doesn't matter if the road can't keep up. Semiconductor industry analyst, highway construction. Light traffic, ordinary roads work fine. As cities grow, roads clog up, so engineers build multi-lane highways and bridges. AI is going through the same shift. The processors keep getting better, but the roads carrying data between them have to scale too. That's why networking companies have become just as important as chip makers in the AI race, and why chip companies increasingly talk about entire platforms instead of individual chips. China seems to be pushing on every layer of that stack at once. Memory manufacturing, advanced chip packaging, optical communication, AI accelerators, photonics, glass-based components, ultra-fast networking. No single announcement tells the whole story, but stacked together, they reveal a deliberate strategy. Build an entire ecosystem for AI, not just isolated wins. Whether that ecosystem ends up the world's strongest is impossible to say. The US, Europe, Japan, South Korea, and Taiwan are all pushing hard too, and plenty of today's lab demos are still years away from real-world deployment. Manufacturing has to scale, costs have to drop, software has to catch up, and industry standards need to evolve. None of that happens overnight. But big shifts in technology tend to start small and unnoticed. Almost nobody grasped the impact of the first semiconductor. Few predicted smartphones would replace cameras, music players, GPS units, and PCs for billions of people. Cloud computing looked unnecessary, right up until it became essential. AI followed the same arc. Years in research labs, then suddenly everywhere. Optical computing inside AI infrastructure could follow that exact same curve. Hyperscalers and top labs first, then falling costs, rising reliability, and eventually it's just normal engineering. The most interesting part of this story isn't really copper at all. It's that AI is forcing engineers to question assumptions that have held for a century. Instead of asking how to make cables slightly better, they're asking whether data should even travel through wires anymore. That's a fundamentally different question. And if China keeps advancing optical networking and photonic communication, the competition might stop being about who builds the fastest chip and start being about who builds the smartest system. The one that wastes the least energy, generates the least heat, and lets AI scale past today's ceiling. Whether this future lands in 5 years or 15,
One thing already looks clear. The AI race isn't just about chips anymore. It's about everything connecting those chips together. The processor that weights the least may end up beating the processor that's simply fastest. And if light really does replace copper for these critical links, we could be watching one of the biggest infrastructure shifts computing has seen in decades. If you enjoyed this video, like, subscribe, and turn on notifications. Every day we break down the biggest tech breakthroughs coming out of China, from AI and semiconductors to photonics, robotics, and next-gen manufacturing. Let us know in the comments, do you think light will eventually replace copper inside AI systems? Or is copper sticking around for good? Thanks for watching, and see you in the next one.